Pluto was demoted from planet, but it was promoted to one of our greatest puzzles. This small, distant world, often written off as a frozen rock, is hiding secrets that rewrite the rules of our solar system. By the end of this journey, you will see Pluto not as a footnote, but as a dynamic and astonishing world brimming with bizarre phenomena. We are about to explore 25 of its most unexplained mysteries, from a beating heart of ice that tips the entire planet over to mountains that float on a frozen sea. How could a place so cold and remote be so incredibly alive? The first and most iconic mystery greets us from the very first close-up image. There, etched across the face of this distant world, is a perfect, colossal heart. This is Tombaugh Regio, a feature so vast it stretches over 1,000 miles across, dominating an entire hemisphere of Pluto. Its western lobe, a remarkably smooth and crater-free plain, is named Sputnik Planitia. This is not a heart of rock, but a heart of ice, primarily frozen nitrogen with traces of methane and carbon monoxide. The profound mystery lies in its very existence. On a world so small and cold, geological activity should have ground to a halt billions of years ago. Yet here is a basin hundreds of miles wide, filled with a glacier so smooth it appears almost polished. What process could possibly erase all the scars of ancient impacts? What force could be actively resurfacing this terrain, keeping it looking newborn? The leading suspicion points to something extraordinary happening beneath the ice. Sputnik Planitia sits in a massive impact basin, a scar from a cataclysmic collision in Pluto's deep past. Scientists now believe this basin may have triggered a chain of events that is still unfolding today. The sheer weight of all that accumulating nitrogen ice could have caused the entire structure to sink, creating a negative mass anomaly, a sort of gravitational dent. This dent, in turn, may have literally tipped the entire planet over, reorienting Pluto so that this icy heart now sits permanently locked opposite its largest moon, Charon. So this beautiful, serene feature is not just a pretty marking. It is a planetary-scale wound, a frozen sea that may have grabbed Pluto and physically twisted it, a process that might still be churning the ice from below with residual, unexplained heat. The heart of Pluto is not a static symbol. It is a dynamic, beating engine of mystery. This immense weight has consequences far beyond a simple dent. The sheer mass of Sputnik Planitia, that vast frozen sea of nitrogen, is so tremendous that it may have physically grabbed Pluto and rolled it over. This process is called true polar wander. Think of it not as the planet spinning on its axis, but as its entire outer shell, the crust, slowly sliding over the inner layers like the skin of a loose orange sliding around the fruit inside. The gravitational tug from that concentrated mass of ice acts as a lever, seeking the most stable position, which is along the equator. Over millions of years, the entire world reoriented itself, placing this heavy, icy heart directly opposite the gravitational pull of its largest moon, Charon, in a permanent gravitational tug-of-war. The heart did not just form on Pluto, it actively reshaped the planet's very orientation in space, but the influence does not stop there. This colossal, cold engine also breathes life into Pluto's whisper-thin atmosphere. As sunlight hits the heart, particularly the smooth nitrogen ice of Sputnik Planitia, it causes the frozen gases to sublimate, turning directly from ice into vapor. This creates daily and seasonal atmospheric pulses. The heart, in essence, exhales, and as these gases rise and flow, they interact with the surface in visible ways. New Horizons captured images of dark wind streaks aligned across mountain ridges and plains, especially to the west of Sputnik Planitia. These are not random markings. They are the footprints of prevailing winds, likely created as these sublimated ices carried dark Tholen particles, complex organic molecules that give Pluto its reddish hue and deposit them downwind like cosmic snowdrifts. The heart is not a passive feature. It is a dynamic driver, a cold, beating pump that reorients the globe and sculpts its skies, creating weather on a world we once thought was geologically dead. Yet this atmospheric breath from the heart creates landscapes of pure strangeness far beyond simple wind streaks. To the east of Sputnik Planitia, bordering the dark, cratered region of Cthulhu Macula, lies a territory that looks less like a planetary surface and more like the petrified spine of a cosmic dragon. This is Tartarus Dorsa, the bladed terrain. Imagine a field of colossal, jagged shards of ice, each one rising hundreds of meters into the sky, as tall as skyscrapers and spaced several kilometers apart. They are not random spikes. From above, they form a hauntingly uniform pattern, a vast collection of parallel ridges that stretch to the horizon, gleaming with a pale, ethereal light. These are not rock formations, they are mountains of solid methane ice, carved into these impossible shapes by a process we are only beginning to understand. The leading theory points once again to sublimation, that same direct transition from solid to gas that powers Pluto's atmosphere. Over millions of years, sunlight would have slowly eaten away at broad deposits of methane ice. But instead of eroding them evenly, it sculpted them into these dramatic, towering blades. The process is thought to be similar to the formation of penitents on Earth, those sharp spikes of snow found in high Andes deserts, where sunlight causes uneven sublimation that leaves behind tall ridges. But on Pluto, the scale is monstrous, planetary. The methane ice is far harder, and the timescales are incomprehensibly longer, allowing for the growth of these monumental structures. Yet this explanation, while compelling, opens up even deeper puzzles. Why is the alignment across such a vast area so perfectly uniform? The blades point in the same general direction, suggesting a prevailing environmental condition that has remained stable for eons. What specific, unvarying mix of sunlight, temperature, and atmospheric pressure was required over millions, perhaps billions, of years to patiently whittle a frozen plain into a forest of icy spears? It implies a climate history on Pluto of astonishing stability, a whisper-thin atmosphere acting with the consistent, delicate precision of a master sculptor. The bladed terrain stands as a frozen record of time itself, a testament to processes so slow and steady they defy our understanding of a dynamic solar system. It is a landscape that could only form in a world of profound and patient cold. That colossal icy heart may be the key to unlocking a secret buried deep within Pluto. The profound mystery of Sputnik Planitia's formation and its planet-tipping weight points to something astonishing hidden beneath the frozen crust. Scientists now see compelling evidence for a vast, global ocean of liquid water sloshing beneath the ice. The strongest clue comes from the heart's own alignment. Sputnik Planitia sits directly on the tidal axis between Pluto and its largest moon, Charon. This is not a random coincidence. It is the most stable gravitational configuration, like a weight settling at the bottom of a spinning top. For that heavy basin to have rolled into that precise position through true polar wonder, the layer beneath Pluto's icy shell must have been soft and malleable enough to allow the entire outer crust to slide. A solid, frozen interior would have locked the crust in place, but a global subsurface ocean of liquid water would provide a perfectly slippery lubricant, allowing the whole world to literally tip over and reorient itself. The impact that created the Sputnik Basin itself adds to the evidence. A giant collision would have blasted away a tremendous amount of ice, creating a massive hole. If Pluto were solid all the way through, gravity would have slowly pulled the crater floor back into a more rounded shape over time. But the floor of Sputnik Planitia remains remarkably flat and smooth, almost perfectly level. This suggests that after the impact, something buoyant welled up from below to fill the gap and support the weight of the new ice that later accumulated. That something is thought to be the upwelling of a denser, slushy layer from the top of the subsurface ocean, a process that created a sort of planetary plug holding the basin in its current shape. This leads to the most tantalizing question of all. Could this hidden ocean, buried under hundreds of kilometers of rock-hard water ice, still be liquid today? The answer hinges on Pluto's internal heat. The dwarf planet should have frozen solid eons ago, yet the presence of young surface features like the smooth plains of Sputnik itself screams of recent geological activity. The heat required to keep an ocean liquid likely comes from the slow radioactive decay of rocks in Pluto's core, combined with the unique antifreeze properties of the water itself. Scientists believe the ocean is not pure water but a briny, ammonia-rich soup. Ammonia acts as a potent antifreeze, dramatically lowering the temperature at which water freezes. This exotic chemistry, coupled with the insulating blanket of the thick ice shell above, could be preserving a dark, alien sea. The implications for potential habitability are profound. On Earth, life thrives around hydrothermal vents on the ocean floor, drawing energy from chemistry, not sunlight. A warm, rocky core at the bottom of Pluto's ocean, heated by radioactivity, could provide similar energy sources and mineral-rich environments. While finding life there remains a distant dream, the simple fact that such an environment might exist in the perpetual darkness at the edge of our solar system transforms Pluto from a frozen relic into one of the most promising places to look for the ingredients of life beyond Earth. But a hidden ocean is not the only force sculpting the heart of Pluto. Within the vast, flat expanse of Sputnik Planitia, New Horizons spotted something that should be impossible: mountains adrift. Scattered across the smooth nitrogen plains are clusters of isolated hills, some as wide as several kilometers across. These are not mere bumps. Spectral data reveals they are made of water ice, which is far harder and less dense than the surrounding plane of softer, denser frozen nitrogen. This creates a surreal inversion of our earthly experience. On Pluto, water ice acts like a cork. These massive chunks of crust are literally floating on the denser sea of nitrogen ice, like icebergs on a frozen ocean. They are the floating hills, a phenomenon that defies simple geology and paints a picture of a world in slow, churning motion. Their origin is a puzzle in itself. One possibility is that these hills are the shattered remnants of Pluto's ancient water ice crust, broken apart by the colossal impact that created the Sputnik Basin. The force of that collision could have sent enormous fragments tumbling across the newborn plain, where they eventually settled and became encased in the flowing nitrogen. Another, even stranger idea is that some of these hills formed in place, welling up from below like blobs of wax in a lava lamp, pushed upward by the slow churn of the ice itself. Regardless of how they began, their current arrangement tells a dynamic story. The hills are not randomly scattered. They are often found gathered in long, organized chains, sometimes dozens of kilometers in length, tracing graceful curves across the plain. This pattern is the key clue. It suggests they are not static. Instead, they are being carried along by immense, slow-moving currents within the nitrogen ice itself. The engine driving this movement is convection. Even at temperatures nearing -400 degrees Fahrenheit, the thick slab of nitrogen ice in Sputnik Planitia is not completely inert. Heat from Pluto's interior, however faint, can create subtle temperature differences between the bottom and top of the ice sheet. This causes the solid nitrogen to behave in a plastic, malleable way over vast timescales. Warmer ice from the bottom slowly rises in giant, sluggish plumes, while colder ice at the surface sinks. These are convective cells moving with the pace of geology. As these currents creep across the plain, they gather the floating water ice hills and push them together, herding them into lines that mark the boundaries between these circulating cells. It is a breathtaking process, a landscape of icebergs silently drifting on a frozen sea, directed by currents so slow that a single hill might take 1,000,000 years to travel a few miles. This is not a dead world. It is a world of profound and patient activity where ice flows like tar and mountains sail on solid air. Yet this slow drift of icy hills is just one color on Pluto's palette. Dominating the equatorial region, in stark contrast to the pale heart, is a sprawling, ominous stain the color of dried blood. This is Cthulhu Macula, a vast, dark region named for the cosmic horror of H.P. Lovecraft's fiction, and its appearance is fittingly alien. Stretching nearly halfway around Pluto's equator, this feature presents a profound mystery of color and chemistry. Its deep reddish-brown hue comes not from rock, but from a complex organic sludge coating the surface known as tholins. These are not simple molecules. Tholins are a tarry mixture of complex hydrocarbons created when simpler compounds like methane and nitrogen in Pluto's thin atmosphere are bombarded by ultraviolet light from the distant sun or charged particles from space. This radiation breaks the molecules apart, and the fragments recombine into larger, more complex structures that eventually snow down onto the surface, painting it in shades of red and brown. The process is similar to what gives Saturn's moon Titan its orange haze and reddish dunes. But on Pluto, the mystery intensifies. Why is this dark material so dramatically concentrated in Cthulhu Macula, while adjacent regions like the bright heart of Tombaugh Regio remain relatively clean? The answer may lie in a delicate and ongoing atmospheric dance. Pluto's atmosphere, though thin, undergoes dramatic changes over its 248-year orbit. When Pluto is closer to the Sun, ice is on the surface, particularly in the brighter, icier regions like Sputnik Planitia, warm just enough to sublimate, releasing fresh methane and nitrogen gas into the air. This creates seasonal winds. Scientists suspect these gentle winds may carry the dark tholin particles across the surface, depositing them in specific areas. Cthulhu Macula, with its older, cratered, and likely water ice-rich terrain, may act like a cosmic flypaper. Its texture and composition could allow it to trap and retain these falling hydrocarbons more efficiently than the smooth, actively convecting nitrogen glaciers of the heart. Furthermore, temperature plays a crucial role. The dark red material of Cthulhu Macula absorbs more sunlight than the bright ice, making that region slightly warmer. This warmth could trigger a feedback loop, preventing volatile ices from settling there and instead encouraging more tholins to accumulate, which darkens the area further, which absorbs more heat, and so on. So this monstrous dark region is not a static scar. It is likely an active chemical refinery, a product of eons of atmospheric photochemistry, seasonal winds, and thermal feedback, creating a distinct stain that tells a story of air, ice, and light playing out over millennia. This dark chemical stain, however, is etched onto a canvas that itself defies time. Look closely at the bright plains of Sputnik Planitia, that vast heart of ice. They are almost perfectly smooth. This observation leads to one of the most profound and unsettling mysteries of all. Pluto has far too few craters. Across vast stretches of its surface, the expected pockmarked record of 4.5 billion years of cosmic bombardment is simply missing. Compare it to a world like Jupiter's moon Callisto, a textbook example of a dead, frozen relic. Callisto's face is a shattered mask, densely packed with overlapping craters, a testament to an ancient surface that has seen no renewal. Pluto, by stark contrast, shows vast regions that are geologically newborn. Some areas, like the cellular plains of Sputnik, may be no more than 10 million years old. In the timescale of the solar system that is yesterday, this sparse cratering is a screaming clue that Pluto is not dead. It is geologically active. Something is constantly erasing the scars, repaving the surface, and keeping this distant world looking fresh. This presents a monumental conundrum. Geological activity requires an internal heat source. For a small, rocky world like Pluto, far from the warming grip of a giant planet, that heat should have bled away into space eons ago. So what hidden furnace is still burning within this icy dwarf, billions of years after its formation? Scientists are probing several possibilities, each fascinating in its own right. The primary suspect is the slow, steady decay of radioactive elements like uranium and thorium locked within Pluto's rocky core. This nuclear furnace provides a long-lasting, if faint, trickle of heat. But is it enough to explain the dramatic resurfacing we see? This heat may need to be amplified or focused. This is where Pluto's intimate dance with its giant moon Charon becomes critical. The two are tidally locked, forever showing the same face to each other as they orbit a common center of gravity. This gravitational embrace could generate tidal heating, much like the forces that churn the oceans inside Jupiter's moon Europa. As Pluto and Charon flex each other's shapes ever so slightly, friction generates warmth. While this heating is likely much weaker than that experienced by moons orbiting gas giants, over billions of years it could provide just enough extra energy to keep Pluto's interior soft and its icy shell mobile. There is also the possibility of chemical heat from the antifreeze-laden ocean itself, or even heat left over from the colossal impact that may have formed the Pluto-Charon binary system. The truth is, we likely need a combination of all these sources: a faint radioactive glow, a gentle tidal squeeze, and exotic chemistry working in concert to power the slow-motion geology that continuously wipes Pluto's face clean. This lack of craters is not an absence, it is a presence. It is the unmistakable signature of a world that is still alive, whispering of hidden fires burning in the deep, eternal dark. But the story of Pluto's atmosphere is not confined to the ground. High above its stained and shifting surface, the dwarf planet wears a crown of ethereal blue. When New Horizons looked back at Pluto after its flyby, capturing the world silhouetted against the sun, it revealed a breathtaking sight. A delicate, multilayered halo of blue haze stretching over 100 miles into the blackness of space. This was not the featureless, gradual fade of a simple gas envelope. It was a structured, tiered atmosphere composed of over 20 distinct horizontal layers of haze, stacked like the pages of a phantom book. The source of this beautiful haze is the same complex chemistry that paints Cthulhu macular dark red, tholins. Up in the atmosphere, ultraviolet sunlight breaks apart methane molecules, and the fragments link up into ever larger hydrocarbon chains. These tiny particles eventually grow large enough to scatter sunlight, creating the visible haze, and their blue color comes from the specific way they scatter the sun's faint, distant light. Yet the existence of these sharp, separated layers is the true puzzle. In an atmosphere as thin as Pluto's, where the pressure at the surface is only 100,000th that of Earth's, you would expect constant mixing. Winds and turbulence should blur these haze particles into a uniform, soupy smear. Instead, they are organized into precise, flat strata. This implies an invisible, rhythmic process is at work, meticulously sorting and stacking the atmosphere. The leading suspect is a phenomenon called gravity waves. These are not the gravitational waves from merging black holes, but a much more local atmospheric effect. Imagine tossing a stone into a calm pond. Ripples spread out across the water's surface. Now imagine similar ripples but traveling vertically through the air itself. On Pluto, these waves could be generated by air flowing over massive surface features like mountain ranges or the towering bladed terrain. As these gentle waves propagate upward through the thin atmosphere, they create alternating bands of slightly denser and slightly thinner air. The tholin haze particles condensing out of the gas naturally collect in the denser bands, painting the ripples into visibility. Each distinct haze layer could be a frozen snapshot of a single atmospheric wave captured in hydrocarbon dust. This means that by studying the spacing and structure of these blue layers, scientists are not just looking at chemistry. They are reading a weather report written across the sky, decoding the subtle interactions between Pluto's winds and its dramatic topography. The serene blue halo is not a static decoration. It is a dynamic, pulsating fingerprint of the air itself, whispering secrets about the invisible forces shaping a world we once thought silent. That serene blue haze holds a secret. It is leaking into the void. Pluto's atmosphere is not a permanent fixture. It is in a state of dramatic, unexpected escape, streaming away into space at a rate that left scientists stunned. The New Horizons data revealed a loss rate 100 to 500 times faster than anyone had predicted. Imagine a world where the very air is being violently stripped away, not over billions of years, but on a timescale that feels almost urgent in cosmic terms. The primary driver of this exodus is Pluto's incredibly weak gravity, only about 6% of Earth's. Holding onto an atmosphere is a constant tug of war between a planet's gravitational pull and the energy of the gas molecules themselves. On a small, cold world like Pluto, that battle is tilted heavily in favor of escape, but low gravity alone does not explain the astonishing rate of loss. The Sun, even from its distant perch, plays a crucial and aggressive role. The solar wind, that relentless stream of charged particles blowing from the Sun, slams into Pluto's thin atmospheric gases. This collision energizes the molecules, giving them the extra kick they need to overcome the dwarf planet's feeble grip and fly off into interplanetary space. It is a continuous, invisible sandblasting of the sky itself, yet the plot thickens with Pluto's unique atmospheric chemistry. The dominant gas is nitrogen, just like Earth, but the similarities end there. Pluto's upper atmosphere is much colder than models anticipated. A colder atmosphere should be denser and more tightly bound, slowing the escape rate. Instead, we see the opposite. This points to an unknown cooling mechanism at work high above the surface, perhaps involving the complex hydrocarbon haze particles themselves radiating heat away more efficiently than expected. Furthermore, methane, though a minor component, acts as a powerful coolant in the upper atmosphere. This efficient cooling might paradoxically be accelerating the loss by creating a steeper temperature gradient that drives more dynamic escape processes. The implications for Pluto's future are profound. At this rate, could the entire atmosphere simply vanish? The answer is likely no, because it is not a one-way street. Pluto's atmosphere is a dynamic, breathing system. The vast reservoir of frozen nitrogen and other ices on the surface, particularly in the heart of Sputnik Planitia, acts as a buffer. As atmosphere escapes into space, the surface ices sublimate to replenish it, maintaining a fragile equilibrium. This is a global-scale balancing act between loss and supply. The real mystery is whether this balance can hold. As Pluto continues its 248-year elliptical orbit, moving farther from the Sun into an even deeper freeze, the sublimation from its icy heart will slow. The supply line to the atmosphere will thin, while the solar wind, though weaker, never completely stops. This could lead to a future where Pluto's atmosphere partially or even fully collapses, freezing out entirely onto the surface as a global layer of fresh frost. We may be witnessing this dwarf planet in a fleeting, dynamic phase of its long history, a temporary whisper of air around a world destined to return to silent, frozen slumber. The runaway atmosphere is not just a leak, it is a countdown clock ticking in the slow motion of geology, measuring the lifespan of Pluto's alien sky. This atmospheric escape does not just vanish into the void. Some of it embarks on a journey to paint another world. Turn your gaze from Pluto to its largest companion, Charon, and you will find one of the most striking and perplexing features in the entire system: a dark, rusty red stain smeared across its north pole. This is Mordor Macula, a name taken from the shadowed land of Tolkien's Middle-earth, and its appearance is just as ominous. The leading theory for its existence is a cosmic theft. As Pluto's atmosphere streams away into space, some of those escaping gases, particularly methane, are captured by Charon's gravity. They drift across the void and settle onto the Moon's frigid surface. But Charon's poles are among the coldest places imaginable. During its long winter, each pole endures decades of continuous darkness, with temperatures plummeting so low that any arriving gas freezes instantly and sticks fast. Over millions of years, these trapped methane molecules are then processed by the same cosmic chemistry that paints Pluto. Bombarded by ultraviolet light and charged particles, they are transformed into the same complex reddish tholins. It is a hauntingly beautiful process. Pluto breathes out its atmosphere, and Charon catches the exhale, using it to daub its own polar cap in shades of blood and rust. Yet this elegant story is riddled with holes. The biggest mystery is one of precision. Why is the red material so perfectly concentrated at the pole? If tholins are snowing down from Pluto, we might expect a more even, global dusting across Charon's surface. The answer lies in Charon's own extreme and unforgiving climate. The poles are not just cold, they are profound cold traps. For nearly a century at a time, they are locked in shadow, utterly devoid of sunlight. Any volatile compound that lands there is frozen in place for eons. In contrast, Charon's equatorial regions experience dramatic temperature swings. When sunlight finally reaches these areas, it is enough to warm the surface and sublimate any thin frost of methane or other volatiles, leaving behind only the bare gray water ice bedrock. The dark red tholins, however, are not volatile. Once created, they are a permanent stain, so the process is a relentless cycle of capture and cook. Methane freezes at the pole, gets irradiated into a permanent red crust, and the surrounding, cleaner ices sublimate away over the seasons, leaving the dark cap in stark, isolated relief. This makes Mordor Macula more than just a splash of color. It is a cosmic record keeper, a chemical vault that has been meticulously collecting and preserving samples of Pluto's lost atmosphere for perhaps billions of years. By studying this alien polar stain, we are not just looking at Charon. We are reading a history book written in stolen air, a testament to the intimate and enduring chemical bond between a dwarf planet and its moon. That stolen polar stain is just the beginning of Charon's story. Beneath its mottled surface lies evidence of a cataclysm frozen in time. Stretching across the face of this moon is a scar so vast it makes Earth's Grand Canyon look like a crack in the sidewalk. This is Serenity Chasma, part of a sprawling equatorial canyon system that runs for over 1,000 miles, nearly 4 times the length of the Grand Canyon and in places twice as deep. Its cliffs tower miles high, plunging into shadows that have likely never seen direct sunlight. This is not a simple crack from an impact. It is a tectonic wound, a sign that the entire globe of Charon underwent a dramatic transformation. The leading theory is one of planetary-scale heartbreak. Scientists suspect Charon once harbored a subsurface ocean of liquid water, much like the one that may still slosh beneath Pluto's ice. But as Charon's interior cooled over billions of years, that ocean began to freeze. Water has a unique property. It expands when it turns to ice. If you have ever left a full water bottle in the freezer and returned to find it burst, you understand the immense force at play. Now imagine that process happening on a global scale. As Charon's hidden sea solidified, the expansion from within would have strained the moon's outer icy shell to its breaking point. The entire crust stretched, fracturing like the skin of an overinflated balloon. Serenity Chasma and its associated canyons are the colossal scars from that epic rupture, a permanent record of the moment Charon's heart turned to ice. This tectonic style stands in stark contrast to Pluto's geology. While Pluto's surface is shaped by the slow, convective churn of ices and the drifting of buoyant hills, Charon's landscape speaks of a single, definitive event, a global freeze that cracked its shell open and then stopped. The canyons are sharp, stark, and largely unmodified, suggesting that after this great fracturing, Charon's geological engine largely shut down. Its surface became a frozen monument to its past. Yet the mystery deepens when we look at the canyon walls themselves. New Horizons imagery reveals varied textures, including long, smooth slopes and areas of jumbled terrain. This suggests the cracking was not a single clean break, but a complex process, perhaps involving the collapse of subsurface voids as the ocean drained or froze. Could there have been slushy mixtures of ice and water oozing out to coat the cliffs? The sheer scale of the chasms also hints that Charon's crust might have been thinner or more brittle than models predict. The story written in those mile-high cliffs is still being translated, a stark reminder that even in stillness there is evidence of a violent and transformative past. But this fractured moon is not alone in its dance. Beyond the intimate binary of Pluto and Charon lies a realm of pure celestial chaos, a miniature solar system in disarray. Orbiting the central pair are four tiny, irregular moons, Styx, Nix, Kerberos, and Hydra, and their motion defies all our expectations of orderly cosmic clockwork. Unlike our own moon, which is tidally locked and shows Earth only one face, or even Charon, which is perfectly synchronized with Pluto, these four small moons are tumbling through space in a state of constant, unpredictable rotation. They spin chaotically, flipping and wobbling like poorly thrown footballs, their days and nights changing length erratically. This bizarre behavior is a direct product of the gravitational maelstrom they inhabit. The primary source of gravity in their world is not a single central point. Instead, they orbit the ever-shifting center of mass between Pluto and Charon, a binary system where two sizable worlds are locked in a tight mutual pirouette. This creates a complex and violently uneven gravitational field. Imagine trying to walk in a straight line while two powerful, spinning magnets are whirling around you, each tugging you in different directions at different times. That is the daily reality for Nix, Hydra, and their siblings. The gravitational pulls from both Pluto and Charon, combined with their own irregular, potato-like shapes, constantly torque and perturb their spins, preventing them from ever settling into a stable, synchronous rotation. Their orbits themselves are also remarkably circular and neatly spaced, which is deeply puzzling given the chaotic environment. How can such orbital order coexist with such rotational anarchy? Scientists believe they are caught in what are called orbital resonances. Their orbital periods are neatly synchronized with each other in simple ratios. For every 3 orbits Charon makes around Pluto, Hydra makes 2, and Nix makes 4. This gravitational harmony likely helps stabilize their paths against the chaotic tides, preventing them from crashing into each other or being flung out of the system entirely. Yet this neat arrangement only deepens the mystery of their origins. The prevailing theory is that they are leftover rubble from the ancient cataclysmic collision that formed the Pluto-Charon binary itself. In that violent impact, debris would have been flung into orbit, eventually coalescing into these small moons. Their wildly tumbling spins and bizarre shapes, Nix resembles a fuzzy football. Hydra looks like a misshapen potato, are frozen signatures of that chaotic birth. They were never shaped by their own gravity into neat spheres. They are jagged fragments, forever tumbling in the gravitational wake of the two giants whose violent marriage created them. These tumbling moons are a visible echo of chaos, but for centuries, Pluto itself seemed to flicker like a distant, unstable star. Long before New Horizons, astronomers watching from Earth documented a haunting and consistent pattern. Pluto's brightness was not constant. Over the decades, it would dim and then brighten again in a slow, repeating cycle. This was one of the oldest puzzles in our study of the dwarf planet, a clue written in shifting light that hinted at a world of profound change. The New Horizons flyby finally gave that flickering a face. It revealed a planet of shocking contrasts, a world painted in extremes. On one side, the brilliant, reflective white of the nitrogen ice-hot Sputnik Planitia, gleaming like a cosmic lantern. On the other, the deep, light-absorbing crimson of Cthulhu Macula, a vast stain so dark it seems to swallow the feeble sunlight. This stark dichotomy between bright and dark is the physical answer to the historical brightness changes. As Pluto spins on its axis and orbits the Sun over its 248-year journey, different hemispheres tilt toward Earth. When the bright heart is facing us, Pluto appears brighter in our telescopes. When the dark equatorial regions are in view, it dims. It is a simple geometric explanation for the observed flicker, yet this answer only opens a deeper, more climatic mystery. These bright and dark regions are not fixed in stone, or rather in ice. They are part of a slow, epic migration. The ices that make Pluto bright, the frozen nitrogen, methane, and carbon monoxide, are not permanently locked in place. Over timescales of tens or hundreds of thousands of years, they are in constant, gradual motion, sublimating from one area and redepositing as frost in another, following the complex dance of Pluto's climate. The driving force is the dwarf planet's extreme axial tilt and its wildly elliptical orbit. Unlike Earth's relatively stable tilt, Pluto's axis is tipped a dramatic 120 degrees, essentially spinning on its side. Combine this with an orbit that sometimes brings it closer to the Sun than Neptune, and sometimes sends it far out into the Kuiper belt, and you have a recipe for climatic chaos. The distribution of sunlight across the surface changes drastically over these million-year cycles. A region that is currently a bright, icy pole could, over millennia, become a warmer equatorial zone, causing its volatile ices to vaporize and travel through the thin atmosphere to condense somewhere else, perhaps at the new poles. This means the face of Pluto, the very map of its bright and dark features, is not permanent. The heart that defines it today may, over cosmic time, fade and drift while new bright caps form elsewhere. The lingering, profound mystery is predicting the precise patterns of this ice migration. We have seen the snapshot from New Horizons, but we lack the million-year time lapse. Which areas are currently gaining ice and which are losing it? How will the dark tholin-stained regions expand or contract as the climate shifts? The varying brightness observed from Earth was not just a viewing angle trick. It was a glimpse of a world in the midst of a slow-motion transformation, its entire global complexion shifting with the ponderous rhythm of orbital mechanics, a face remade by time and distance. Amid these slow climatic shifts, Pluto seems to harbor mountains that once roared. Rising from the dark, cratered plains south of Sputnik Planitia are two colossal and bizarre structures, Right Mons and Pickard Mons. These are not jagged peaks or floating hills. They are immense, smooth, domed mountains, each over 100 miles across and several miles high, and each crowned with a deep, central depression, like a giant's thumbprint pressed into their summits. To planetary geologists, their shape is hauntingly familiar. They bear an uncanny resemblance to shield volcanoes on Earth and Mars, like a cosmic version of Hawaii's Mauna Loa. But on a world of deep cold, these would not be volcanoes of fire and molten rock. They are candidate cryovolcanos, mountains that may have once erupted a strange, slushy lava of water ice, ammonia, and other antifreezes, a frozen slurry from the hidden ocean below. This cryomagma would not flow like fiery basalt. It would ooze, a thick, sluggish paste, slowly piling up layer upon layer to create those broad, gentle slopes. The central depression could be a collapsed caldera, the point where the last of the slush drained back underground after an eruption. The very existence of such features challenges our understanding of Pluto's interior. For cryovolcanism to occur, the subsurface ocean must not only exist, but it must have found a way to pressurize and fracture the overlying ice shell, sometimes dozens of kilometers thick, and force its way to the surface. It implies periods of significant geological stress and thermal activity in the relatively recent past. Yet the case is not closed. Alternative explanations whisper of other possibilities. Could these domes be created by the upwelling of denser material from below, a process called diapyrism, where a blob of warm ice slowly punches through the crust like a blister? Or are they the result of some exotic form of extreme glacial activity we have yet to comprehend? The composition of the cryomagma itself is another enigma. Spectra from New Horizons show these regions are covered in water ice, but with an unusual amount of ammonia hydrate mixed in. Ammonia is the key. It acts as a powerful antifreeze, lowering the freezing point of water by hundreds of degrees. A briny, ammonia-rich slurry from Pluto's ocean could remain liquid enough to flow, or at least be ductile at temperatures far below what pure water ice could tolerate. This suggests that if right Mons did erupt, it did not spew molten rock but a cold, toxic slush, a mixture that would quickly freeze into the bizarre landscape we see today. The haunting question remains, are we looking at extinct volcanoes, their internal fires long since cooled, or merely sleeping ones? Their relatively crisp, uneroded appearance suggests they could be young, perhaps only a few 100 million years old. This means the engine that built them, Pluto's hidden heat, might still be capable of a final, frigid eruption. These mysterious mountains stand as silent sentinels, perhaps guarding the last passageways to a dark, alien sea. The dark plains of Cthulhu Macula are more than just a stain. They are a window into Pluto's ancient past. This sprawling, rust-colored region presents a fundamental puzzle about the very bedrock of the dwarf planet. What exactly lies beneath that dark veneer? Spectral data from New Horizons provides a crucial clue. It shows that the dark areas are rich in water ice, the hardest and most durable ice in Pluto's frigid environment. This suggests that Cthulhu Macula is likely an exposure of Pluto's primordial crust, a billion-year-old landscape of water ice that has survived virtually unchanged since the solar system's youth. The dark reddish-brown coating is then a later addition, the complex Tholen sludge that snows down from the atmosphere, accumulating over eons like a layer of cosmic soot. But why does this dark material cling so tenaciously to these specific plains and not others? The answer may lie in texture and temperature. The ancient water ice crust here is likely rough and heavily cratered, providing countless microscopic nooks and crannies for the Tholen particles to settle into and become trapped. In contrast, the brilliantly white plains of Sputnik Planitia are a dynamic, convecting glacier of softer nitrogen ice. Its surface is constantly being renewed from below, like a slowly churning icy lake, and this active process likely buries or recycles any dark material that falls on it before it can accumulate. Furthermore, the dark tholins themselves create a thermal feedback loop. Because they are dark, they absorb more of the sun's feeble heat, making the region slightly warmer. This warmth prevents volatile ices like nitrogen, methane, and carbon monoxide from condensing there as frost. Those bright, volatile ices preferentially settle on the colder, brighter regions, further accentuating the contrast. So the stark division between light and dark on Pluto is not random. It is a direct map of geological activity versus geological stagnation. The bright heart is alive, its surface young and mobile, actively rejecting the dark coating. The dark plains are a museum, an ancient, stable exhibit where the grime of the ages has been allowed to collect undisturbed. This dichotomy tells a story of two Plutones existing side by side, one a dynamic, evolving world, and the other a preserved relic from its deepest past, forever stained by the chemistry of its own sky. Yet the stark contrast between light and dark on Pluto's surface points to a deeper, more fundamental puzzle. How can a world so far from the sun manage its temperature at all? This leads us to a core climatic mystery, the temperature paradox. By all rights, Pluto should be a bit warmer than it actually is. Based purely on its immense distance from the sun, receiving only a fraction of a percent of the sunlight we do, simple models predicted an average surface temperature around -380 degrees Fahrenheit. But the actual measurements from New Horizons were even more extreme. The surface hovers closer to -400 degrees Fahrenheit. That is a difference of about 20 degrees, which in the realm of cryogenic physics is a massive and meaningful gap. Something on Pluto is acting like a planetary-scale air conditioner, making an already unimaginably cold world even colder. The primary suspect is Pluto's own beautiful blue haze. That layered shroud of hydrocarbon particles, while stunning to look at, plays a crucial thermal role. These tiny Tholen particles are exceptionally good at scattering and reflecting sunlight back into space before it can ever reach the surface to provide warmth. It is like a global, high-altitude sunshade, casting a permanent cooling shadow over the world below. But the haze is only part of the refrigeration system. The surface ices themselves contribute in a profound and active way. When sunlight does manage to reach the plains of frozen nitrogen in Sputnik Planitia, it does not simply warm the ice. Instead, it provides the energy needed for sublimation, the direct transition from solid to gas. This process requires a tremendous amount of energy, known as the latent heat of sublimation. In essence, the sun's energy is not used to heat the surface. It is used to rip molecules directly off of it, turning ice into vapor. It is the same principle that makes you feel cold when you step out of a swimming pool. The evaporating water carries heat away from your skin. On Pluto, this is happening on a continental scale. The vast heart of nitrogen ice is a giant, slow-motion refrigerator, using incoming solar energy not to warm up, but to actively cool itself down by fueling the phase change of its own surface. This creates a delicate and counterintuitive energy balance. The more sunlight hits these bright, volatile ice sheets, the more they sublimate, which cools the surface further, which in turn can influence atmospheric pressure and wind patterns. This sublimation-driven cooling may also explain some of the dramatic temperature contrasts across the surface. The dark, Tholen-stained regions of Cthulhu Macula absorb more sunlight and should be warmer, and they likely are, which is why they lack bright, volatile frost. But what about those candidate cryovolcanos, Wright and Pickard Mons? If Pluto's interior still holds geological warmth, could there be localized hotspots where the heat from a slushy upwelling or a recent eruption slightly warms the surface? Detecting such subtle variations from a single flyby is incredibly difficult, but the possibility remains tantalizing. It suggests that beneath the global chill, there might be whispers of warmth, places where the cold grip of the haze and sublimation is challenged by the faint, deep fire of a world that refuses to be completely frozen. The temperature paradox forces us to see Pluto not as a simple, inert ice ball, but as a complex climate machine where air, ice, and sunlight interact in a fragile dance to create a cold that is even deeper than space itself should allow. The profound cold of Pluto today is a whisper of its fiery, catastrophic birth. To understand the strange world we see now, we must rewind the clock over 4 billion years to a time of chaos and collision in the early solar system. The leading theory for the origin of Pluto and its entire family is a story of staggering violence, the giant impact hypothesis. Picture not the Pluto we know, but a larger proto-Pluto, a young world orbiting in the crowded outer solar system. According to the model, this ancient body was struck a glancing blow by another massive object, perhaps one-third its own size. The impact was not a direct, shattering hit, but a sideswipe of cosmic proportions, a collision that would have been brighter than a billion suns. The energy released was so immense it did not just leave a crater. It vaporized a huge portion of both bodies, sending a swirling, incandescent disk of molten and gaseous debris spinning into orbit around the wounded, reformed core of Proto-Pluto. From this searing ring of wreckage, the largest fragments quickly coalesced through gravity, cooling and solidifying into the world we now call Charon. This explains their intimate binary dance. They were born from the same cataclysmic event, forever linked by shared origin. Yet this elegant story is riddled with unresolved questions. The first and most glaring is the sheer size of Charon. With a diameter just over half that of Pluto, it is the largest moon relative to its parent planet in our entire solar system. This ratio is bizarre. For an impact to create such a massive companion, the collision had to be exquisitely precise. A fast, grazing blow that injected just the right amount of material into orbit without completely destroying both bodies. Was this a freak accident, or were such giant impacts common in the early Kuiper belt? We simply do not know. The second major puzzle is the impactor itself. What was it made of? Was it a rocky body, an icy body, or a mixture? The answer is locked in the chemistry of the system today. Pluto and Charon have similar but not identical compositions. Pluto appears to have retained more of the volatile, lighter ices like nitrogen and methane, which may hint that the impactor was richer in rock, stripping away some of Proto-Pluto's original icy mantle. By decoding the subtle chemical differences between the two worlds, we hope to reconstruct the recipe of the ancient projectile. Finally, there is the mystery of the four small, tumbling moons, Styx, Nix, Kerberos, and Hydra. If they formed from the same debris disk as Charon, why are they so small and far out? Their neat, circular orbits suggest they coalesced peacefully from the leftover material, but their chaotic spins tell a story of a violent, turbulent nursery. Perhaps they are not primordial at all, but fragments from later collisions between smaller bodies in the disk, a second generation of chaos born from the first. This single, ancient impact is the key that unlocks every other mystery. It could explain Pluto's hidden ocean formed from the residual heat of the collision. It could explain the strange composition of its surface ices and even the dynamic heart that tipped the planet over. The entire Pluto system, in all its beautiful, frozen strangeness, is the scar tissue from a wound 4 billion years old, a fossilized moment of creation by destruction. That ancient, violent birth left its mark not just in global scars, but in textures of almost alien intricacy. In the highlands east of Sputnik Planitia, New Horizons captured a landscape that defies all familiar geology. They call it the snakeskin terrain, and the name is a perfect fit. From a distance, it looks exactly like the scaled hide of some colossal, petrified serpent, or perhaps the deeply grooved bark of an ancient tree. Zooming in reveals the unsettling detail. The entire region is covered in a regular, repeating pattern of long, parallel ridges and intervening pits, each ridge only a few miles long and separated by narrow troughs. The pattern is not random chaos. It is organized, almost geometric, covering hundreds of miles. This is not the work of wind or simple erosion. It appears to be a fundamental property of the ground itself, as if the very bedrock of Pluto was woven or corrugated. The material here is primarily water ice, the hard, durable shell of the dwarf planet. But something has worked upon this ice with a patient, relentless force to etch this bizarre texture onto a continental scale. The leading suspect, once again, is sublimation. Sunlight hitting the surface could cause the water ice to transition directly to vapor, but in a highly uneven way. Slight differences in composition, grain size, or even the angle of the slope could cause some microscopic areas to sublimate faster than others. Over millions of years, this preferential erosion might slowly excavate the pits and leave behind the sharp ridges, like a cosmic woodcarver patiently chiseling a block of ice. Yet sublimation alone feels insufficient to explain the remarkable uniformity and alignment of the pattern. This has led scientists to consider another, more internal force, thermal contraction. As Pluto's interior slowly cools over billions of years, its icy crust contracts, much like mud cracking as it dries. But on a global scale, this contraction would create immense stress, and that stress needs to be released. The snakeskin pattern could be the visible expression of that release, a network of fractures and folds created as the entire skin of the world tightened and buckled. The ridges might be the upturned edges of giant, cracked plates, while the pits are the sunken troughs between them. What makes this terrain so uniquely perplexing, however, is that it likely requires both processes working in concert. The thermal contraction first creates a vast, fragile network of weaknesses in the ice. Then, sublimation acts as the master sculptor, exploiting those cracks and fractures, widening the troughs and sharpening the ridges over eons of gentle, persistent etching. No single earthly process provides a perfect analogy. It is not quite like penitence, not exactly like mud cracks, and only vaguely similar to certain types of eroded sedimentary rock. The snakeskin terrain is Pluto's own signature, a cryptic text written in ice and stress, a testament to the slow, patient, and utterly alien forces that shape a world where the very ground can be woven into scales. This woven snakeskin of ice is not a static tapestry. It is a fleeting pattern in a climate of epic extremes. Pluto's seasons are not the gentle progression we know on Earth. They are a slow-motion apocalypse driven by the dwarf planet's wildly elliptical orbit. For 248 years, Pluto completes one staggering journey around the Sun. At its closest approach, it actually dips inside the orbit of Neptune, bathing in slightly more solar warmth. At its farthest, it retreats into the deep freeze of the Kuiper belt, where the Sun is little more than the brightest star in a perpetual night sky. This orbital roller coaster, combined with Pluto's extreme axial tilt, creates a climate system of almost unimaginable drama. The mystery for scientists is not just that these seasons exist, but predicting exactly how they play out. Where do the planet's volatile ices, the nitrogen, methane, and carbon monoxide, migrate to over these multi-century cycles? When the heart of Sputnik Planitia is tilted toward the Sun and its nitrogen ice sublimates into the growing atmosphere, that gas does not simply vanish. It must travel through the thin air and eventually freeze out again somewhere else, like a global game of hide and seek played over millennia. But where? Does it snow down at the opposite pole, building a new, temporary polar cap? Or does it coat mountain ranges and highlands in a thin, bright frost, subtly redrawing the map of light and dark we see from Earth? Our single snapshot from New Horizons captured just one moment in this epic cycle. We have no time lapse, leaving us to guess at the transformations already underway. Even more dramatic is the fate of Pluto's atmosphere itself. As the dwarf planet swings away from the Sun into its long, deep winter, the temperature plummets further. The supply of sublimating gas from the heart slows to a trickle, while the relentless escape to space continues. Models suggest the atmosphere may partially or even fully collapse, freezing out entirely onto the surface as a global layer of fresh frost. Then, as Pluto slowly curves back toward the Sun over a century later, that frost reawakens, sublimating once more to rebuild the sky from scratch. This means the delicate blue haze and layered structure New Horizons saw might be a temporary phenomenon, a fleeting breath in a cycle of collapse and rebirth. Understanding this volatile transport is a monumental puzzle. It is a complex interplay of orbital position, axial orientation, surface temperature, and even the color and texture of the ground, which determines how much heat it absorbs. Dark areas like Cthulhu Macula warm up faster, potentially becoming sources of sublimation themselves at certain seasons, while bright areas reflect light and stay cold. The entire climate system is a sluggish, planet-wide engine, shuffling ices from one hemisphere to another and turning the atmosphere on and off, all to the ponderous rhythm of a 248-year heartbeat. The slow-motion seasons of Pluto culminate in a spectacle of frozen rivers, flowing down from the rugged highlands that border the western edge of Sputnik Planitia are unmistakable, sinuous features, glaciers. But these are not rivers of water ice. They are glaciers of solid nitrogen, creeping from the mountains into the vast, flat basin in a direct and stunning parallel to glacial flows on Earth. New Horizons captured their telltale signs, lobate fronts, surface flow lines, and channels that clearly show material has moved from a higher elevation to a lower one. This is active, ongoing geology on a world we once thought frozen in time. The profound mystery lies in the very nature of the ice itself. How can solid nitrogen, even at -400 degrees Fahrenheit, possibly flow? The answer is found in its exotic physical properties. On Pluto, nitrogen ice is not a brittle, rigid solid like the water ice in your freezer. At those extreme temperatures and under the pressure of its own immense weight, solid nitrogen becomes plastic and malleable. It behaves more like warm wax or a very thick, slow-moving putty. This allows it to deform and flow over astronomical timescales under the relentless pull of gravity. The process is called solid-state convection, and it requires only the faintest whisper of internal heat to get started. The minimal warmth from Pluto's radioactive core, perhaps just a few degrees above the surrounding chill, is enough to create a critical temperature difference between the bottom and top of the nitrogen ice sheet. Warmer ice at the base becomes even more pliable, allowing it to slowly rise in giant, sluggish plumes, while the colder, brittle ice at the surface sinks. This sets up a creeping, circular motion within the ice itself. When this plastic ice is channeled into a valley or a slope from the highlands, it behaves exactly like a terrestrial glacier, flowing downhill, carving the landscape, and eventually spilling out onto the plains of Sputnik. The timescales are almost incomprehensible. A nitrogen glacier might advance only a few millimeters per year, but given millions of years, these frozen rivers can sculpt mountains and fill basins. This means the stunning heart of Pluto is not a static, frozen lake. It is a dynamic, nitrogen-based cryosphere, actively fed by glacial flows from the surrounding highlands, a slow-motion hydrological cycle playing out with an ice that flows at temperatures where almost everything else is locked in absolute rigidity. Flowing from those frigid glaciers is a chemical clue that could unlock the ocean beneath. In specific regions, particularly around the strange, mountainous features like Right Mons, New Horizons detected a spectral fingerprint that sent a jolt of excitement through the science team: ammonia hydrates. This is not a simple ice. Ammonia, a compound of nitrogen and hydrogen, acts as one of the most potent antifreezes known to science. When mixed with water, it dramatically lowers the freezing point, allowing a briny slush to remain liquid, or at least malleable, at temperatures far below what pure water ice could ever tolerate. Its presence on the surface is a monumental clue, a chemical flare signaling that Pluto's internal workings might be far more dynamic and habitable than we ever dared to hope. The profound mystery lies not in its existence but in its journey. How did this ammonia reach the sunlight? One compelling possibility is that it was vomited up from the depths. If Right Mons is indeed a cryovolcano, then the ammonia-rich water ice on its slopes could be the frozen remains of its last eruption, a cryomagma that oozed from a subsurface ocean, carrying this crucial antifreeze to the surface. This would be direct evidence that Pluto's hidden sea is not just water, but a complex, chemically rich broth, precisely the kind of environment that could, in theory, support the chemistry of life. Yet other explanations whisper from the void. Could this ammonia be primordial, a relic from the very formation of the solar system, locked away in Pluto's deep interior for billions of years and only recently exposed by cracking or erosion? Or was it delivered from above, painted onto the surface by the impacts of ammonia-rich comets over the eons? Each source tells a different story about Pluto's history and potential. If it's primordial and now exposed by geology, it suggests recent violent upheaval from within. If it was delivered by comets, it paints Pluto as a more passive collector of cosmic ingredients. But the association with those peculiar mountains strongly hints at an internal, active source. The spectral signature of ammonia is more than just a chemical reading. It is a potential roadmap pointing directly from the frozen surface down to a dark, warm, and strangely inviting sea. This global choreography of ice and rock extends far beyond any single feature. Look at a map of Pluto and a startling pattern emerges. The vast, bright heart of Sputnik Planitia is not randomly placed. It sits directly opposite the gravitational pull of its giant moon, Charon, on the tidal axis. But the alignment does not stop there. The massive mountain ranges that form the western border of the heart, such as the Hillary and Norgay Montes, run in long, linear chains that seem to frame the basin. Even the sprawling, dark expanse of Cthulhu Macula and the bizarre snakeskin terrain to the east appear organized in relation to this central point. This is not a coincidence. It is a planetary-scale signature, a fossilized record of immense forces that have stressed and stretched Pluto's entire crust. Deciphering this global alignment is like finding a master blueprint for the dwarf planet's tortured history. The leading suspect is the monumental event of true polar wander, the same process that tipped the planet on its side. As the heavy heart of nitrogen ice caused Pluto's outer shell to slide over its interior, the entire crust would have been subjected to tremendous directional stress. Mountain ranges could have been thrust up along the edges of the sliding plates, like wrinkles forming on a rug that is being dragged across a floor. The linear faults and fractures we see radiating from the basin may be the scars of that global reorientation frozen in time. Yet Charon's constant gravitational tug adds another layer of complexity. The two worlds are locked in a perpetual embrace, and that tidal force could create persistent stress patterns, subtly encouraging cracks and mountain building along specific, stable lines. Even the slow, churning convection cells within Sputnik Planish's ice might exert outward pressure on the surrounding highlands, pushing up those border ranges like dough rising at the edges of a pan. The truth likely involves all these titanic forces: a sinking basin, a tipping planet, a tugging moon, and a churning ice sea, all working in concert over billions of years. This grand alignment tells us that no feature on Pluto exists in isolation. The heart, the mountains, the dark plains, and the fractured terrain are all interconnected characters in a single, epic geological story. A story of a world cracked, stretched, and sculpted by the slow, relentless dance of gravity and heat. But that global alignment of mountains and plains is mirrored by patterns on a much smaller, more intricate scale. Within the vast, pale expanse of Sputnik Planitia, the heart of Pluto is not a smooth, featureless sheet. From high above, it resolves into a breathtaking mosaic of irregular polygons, each cell spanning 10 to 20 miles across. These are not flat tiles, but shallow depressions, a network of sunken troughs and raised, hummocky borders that together look like the skin of a giant, frozen dragon or a colossal, cracked mudflat. This is the cellular terrain, a landscape of pits and troughs that reveals the slow, churning heartbeat of the nitrogen ice itself. The explanation for these polygons points to a process familiar on Earth, but operating in an alien medium, convection. Even in the profound cold, the thick slab of nitrogen ice is not perfectly still. The faint, residual heat from Pluto's interior, perhaps just a few degrees warmer than the surface, creates a critical temperature difference. Warmer ice at the very bottom of the sheet becomes slightly less dense and more pliable. Over millions of years, this buoyant ice begins to rise in giant, sluggish plumes. Meanwhile, the colder ice at the surface, chilled by the void of space, becomes denser and slowly sinks. This sets up a circular, overturning motion within the solid ice, forming individual convection cells. The raised borders between the cells are where the upward flowing ice spreads out and then descends, while the centers of the cells, the pits and troughs, are where the colder surface ice is actively sinking back down. It is a slow motion roiling, like a pot of thick syrup simmering on the lowest possible heat. The profound mystery, however, lies not in the process but in the power source. What is the specific heat that keeps this pot simmering? Nitrogen ice should be an excellent insulator, trapping any internal warmth. So is the driving heat simply the faint, leftover glow from the radioactive decay in Pluto's rocky core, a billion-year-old ember still providing a whisper of warmth? Or is the engine more cleverly designed? Another possibility involves the ice acting as its own blanket. As sunlight hits the surface, it causes the topmost layer of nitrogen to sublimate directly into gas. This process, which cools the surface, might also leave behind a thin, porous layer of residual, harder material, perhaps water ice or complex organics. This dusty sublimation lag could act like a layer of froth on a cup of coffee, providing exquisite insulation that traps the minimal geothermal heat below, focusing it to drive the convection in the nitrogen layer beneath. The exact recipe of heat and insulation remains unknown, but the result is undeniable. Those polygonal pits are not static cracks. They are the visible, frozen signatures of a churning engine, proof that even in the deepest freeze, Pluto's heart is not just beating, it is slowly, patiently stirring. The churning polygons of the heart point to a world constantly remaking itself, which forces a deeper, almost philosophical question about Pluto's very identity. If its surface is so young and active, where is its original skin? On worlds like our own moon or Mercury, we see vast, dark plains called Maria, but also sprawling, ancient highlands pockmarked with craters, a clear record of the primordial bombardment that shaped the early solar system. New Horizons scanned Pluto from pole to pole, and while it found a staggering variety of landscapes, it never found a single, unambiguous example of that kind of primordial terrain. There is no vast, dead region saturated with overlapping craters, no clear window back to its birth 4.5 billion years ago. This absence is as profound a mystery as any of the flashy features we have explored. It suggests one of two staggering possibilities, both of which challenge our understanding of how small, icy worlds evolve. The first possibility is that Pluto has experienced near-global resurfacing in the geologically recent past. Some planet-wide event or process effectively hit the reset button, erasing the ancient cratered record and paving over almost the entire world with new ice. This could have been driven by the colossal impact that formed the Sputnik-Planitia Basin, an event so violent it may have triggered volcanic or cryovolcanic activity across the globe, flooding low-lying areas with slushy cryomagma. Or it could point to a more gradual but relentless process where the slow churn of convection in vast ice sheets, combined with the seasonal migration of volatile frosts, has continuously erased old scars over billions of years, never allowing a single region to remain untouched long enough to accumulate a dense cratering record. The second, even more transformative possibility is that Pluto's primordial material never looked like what we expect. The building blocks of the Kuiper belt are rich in volatile ices and complex organics. Pluto's original crust may have been a soft, malleable layer of these primitive materials, not the hard, rigid water ice we see exposed in places like the dark Cthulhu macula. Over eons, as internal heat and chemistry worked upon this primal sludge, it could have been thoroughly processed, cooked, and transformed. The dark red tholins coating the oldest terrains might be the literal residue of this alchemical transformation. The charred and recycled remains of the original surface, now buried under newer ice or clinging only to the highest, most stable peaks. In this view, the ancient crust is not missing. We are looking at its ghost, its chemical echo, thoroughly remade by time and internal warmth. The answer likely lies somewhere in between. Isolated, heavily cratered patches might exist in areas New Horizons could not see in high resolution, or they may be hiding beneath a thin veneer of modern frost. But the overwhelming evidence points to a world that has been geologically vigorous for much, if not all, of its long life. The missing primordial surface is not an oversight in our observations. It is a declaration. It tells us that Pluto, against all odds, has managed to sustain a dynamic engine within its small, cold frame for ages, actively burying its own deepest past under layers of icy renewal. The absence of a primordial surface is a testament to Pluto's enduring dynamism, a quality that extends all the way to the edge of its fragile sky. Out there, in the sunlit void, another relentless force is at work. Pluto has no global magnetic field to shield it, Unlike Earth, which is cocooned within a protective magnetic bubble that deflects the torrent of charged particles from the Sun, Pluto stands naked. Its thin atmosphere and icy surface are exposed to the full, unimpeded fury of the solar wind. This sets up a confrontation of staggering scale, where a dwarf planet's wisp of an atmosphere meets a supersonic river of plasma. The data from New Horizons revealed something astonishing. Pluto does not simply get sandblasted. It creates a unique hybrid interaction in space, a complex and beautiful physics experiment playing out in real time. As the solar wind slams into Pluto's atmosphere, it does not hit a solid barrier. Instead, it encounters a gradually thickening cloud of gas. The charged particles of the solar wind push against this gaseous obstacle, slowing down and piling up, creating a bow shock upstream, a permanent, invisible wave in space, like the bow wave of a boat moving through water. But the interaction is gentler and more extended than at a planet with a magnetic field. The solar wind particles gradually infiltrate, ionize, and energize the upper layers of Pluto's atmosphere, giving molecules the kick they need to escape. This is a primary driver of the atmospheric loss we discussed earlier, a continuous stripping by stellar gale force winds. Yet within this violent process lies a potential for eerie beauty. On Earth, auroras are born when solar particles, channeled by our magnetic field, strike atmospheric gases and make them glow. Pluto has no magnetic field to guide the particles, but the solar wind strikes its atmosphere directly. Could this bombardment create a diffuse, global aurora, a faint, ethereal glow within those layered hazes? The physics is different, but the possibility is real. Charged particles exciting nitrogen and methane molecules in the upper atmosphere could produce a very faint, uniform light, perhaps visible only from space, painting the entire haze layers in a subtle, otherworldly luminescence. This means that high above the dark plains and icy heart, in the perpetual twilight of Pluto's sky, there might be silent, permanent northern lights, a ghostly radiance born from an endless, invisible storm. The greatest mystery of Pluto may be the one we have not yet been equipped to solve. New Horizons was a breathtaking reconnaissance, a single, fleeting snapshot in time that transformed a pixelated dot into a world of profound wonder. Yet by its very nature as a flyby, it left the deepest questions hanging in the silent dark. We saw the hints of a subsurface ocean, the scars of global tectonics, and the stains of complex chemistry. But we could not linger to listen for the ocean's pulse or watch the seasons turn. The next great leap in understanding demands not a passerby, but a resident, a dedicated Pluto orbiter. Imagine the revelations such a mission could unlock. An orbiter could map the entire surface in exquisite detail, tracing the subtle migration of ices over seasons we have only modeled. It could use radar to peer directly through the icy shell, searching for the reflective signature of liquid water dozens of kilometers below, finally confirming or denying the hidden sea. It could monitor the candidate cryovolcanos like Right Mons for any faint signs of gaseous plumes or thermal anomalies, evidence that those frigid mountains are not extinct but merely sleeping. It could analyze the composition of the surface and atmosphere with a precision far beyond a fast-moving flyby, perhaps discovering even more complex organic molecules, the kind that serve as the building blocks for life as we know it. Every mystery we have explored, from the planet-tipping heart to the chaotic tumbling of the small moons, from the atmospheric escape to the global alignment of features, demands sustained observation to unravel. A single data point cannot chart a curve, a single glance cannot reveal a life. An orbiter would give us the time to watch Pluto breathe, to see its climate in motion, and to understand it as the dynamic system it truly is. The ultimate secret of this distant dwarf planet almost certainly lies not on its stained and sculpted surface, but beneath it in the darkness of a possible ocean, warmed by radioactive decay and enriched by alien chemistry. To seek that answer is to venture to the very frontier of our solar system, not for a quick visit, but for a long and patient vigil. The future of Pluto exploration is a promise to return to this astonishing world and finally hear the story it has been whispering across the gulf of space for 4 billion years. Pluto has always been more than a dot in a telescope. It is a world of breathtaking contradictions, a symphony of ice and fire playing in the deepest cold. This journey through 25 unexplained mysteries has revealed a place that defies every simple label. We have seen a heart of ice that tips a planet over, mountains that float on frozen seas, and glaciers that creep at temperatures where physics seems to pause. We have found hints of a hidden ocean, witnessed an atmosphere that breathes and escapes, and decoded landscapes etched by patient forces over billions of years. Pluto is not a dead rock at the edge of our solar system. It is a complex, active, and astonishing world, a testament to the endless creativity of nature. Its mysteries are not failures of understanding, but invitations to look deeper, to wonder more. So tell us, which of these 25 mysteries captured your imagination the most? Was it the churning polygons of the heart, the stolen red stain on Charon's pole, or the possibility of a dark, briny sea? Share your thoughts in the comments below. If you are captivated by this distant, enigmatic world, be sure to subscribe for more journeys into the deepest space mysteries. And the next time you look up at the night sky, remember that faint, wandering dot. Remember Pluto and know that even in the furthest dark, there are worlds alive with wonder waiting for us to understand.